Now, the last topic of this chapter is arbitrage pricing theory, APT. APT is started by the Ross in 1970s, and he tried to overcome the problem of CAPM initially. So the problem CAPM is now there are a lot of assumptions they make. So although the multifactor model is actually too, there are a lot of assumptions we make. Like previous slide, there are lots of assumptions. Information symmetric, that everybody should be rational, so everybody has to have same expectation, things like that. There are lots of assumptions. It's binding conditions. If those binding conditions are violated, then the model is not valid, right? So even though the principles are valid, there are lots of problems. Second problem is again single factor model problem. There's only one factors that may be used, which is the market risk premium, to explain the risk premium of the individual asset. So arbitrage theory starts from the concept of the arbitrage, first of all. So we have to know what arbitrage is. Arbitrage is you can create the positive returns without any risk. So no risk and return. This is violation of actually the if it's a market, right? Because risk return trade-off says that there's no way to get the returns without taking any risk. But there's some case that we can make it. So let's start from the assumption that we can create this arbitrage portfolio. So APT starts from the single index model. Now let's start from the single index model, okay, which is the model that say that again the risk premium of individual asset equals to beta times expected return market, and then there's alpha factor and there epsilon. It's the error term, right? Suppose we have the portfolio that has positive alpha. So say here. So there's one risky portfolio actually, P, with your beta P is a beta, and alpha is positive. So you have excess returns basically. Now, if you invest P, so you buy Phi, and then short the market portfolio, which is M, which is beta M equals to 1, then we can actually short this M, right? So because we're shorting it, then we can actually hedge, so eliminate the systematic portion of the risk, because the systematic portion of the risk is away by shorting the market portfolio. So here, benchmark portfolio. So let's say you basically have portfolio P and you have market factor. Okay. And shorting it. Then you can create the portfolio that generate this only alpha and the error term. So again, risk premium of I equals to beta of portfolio, so it's a portfolio, right? Times market risk premium plus alpha plus pump specific, right? Now this is gone, so we only left this one. And we don't have any risk here. We only have alpha, right? Now we have still this risk. This is firm specific risk, right? So to make this portfolio perfectly arbitrage, so no risk, then we have to eliminate this risk away by forming well-diversified portfolio. So if this portfolio is well-diversified portfolio, now again, by shorting market portfolio, we can eliminate systematic portfolio, and so this is gone, right? And then we can also eliminate the prompt specific non-systematic by forming well-diversified portfolio, and delete arbitrage portfolio. Positive return, which is alpha, and risk-free portfolio. Okay. So that's the starting point. So if you form highly well-diversified portfolio, now we can eliminate just from specific risk away, right? So APT, now this is away. Now we only have this factor left. Again, very similar to CAPM, but the good thing for the APTs, we don't have to make assumptions. We only just try to create the arbitrary portfolio and finding that, well, we can eliminate the specific risk away by forming just well-diversified portfolio. Still this model valid, right? And the return is well-diversified portfolio is like that. Same as CAPM model is one factor. So this is factor one. Now, how to form the well-diversified portfolio? Now, let's look at this table. This table has largest capitalization stock in S&P 500, and found that only 10 companies, which is like 10 out of 500, right? 5%, 2% actually, and the proportion of the market value is about 17.33%. So S&P 500 may be good measures of the well-diversified portfolio. So you can probably use these portfolios as a proxy of the good well-diversified portfolio. So let's basically find the regression between the S&P 500 portfolio and the benchmark market portfolio. So it's complete market portfolio, and you find this error term. Actually, this is about an error terms, and found that annually it's about 2% error. 2% error. So finally, the 2% error is good for just having the S&P 500 as a good proxy variable. We don't know actually, but at least we know that well, this is the annual standard deviation about the T-bill. Okay, so you basically have, this is kind of a little hard concept. So you have kind of 2% error between the S&P 500 portfolio and benchmark portfolio. Now the error for the other alternative, which is T-bill, is about 0.5 to 1.5% from this model. Well, we don't know if really this is good, 2% is good or not, but at least we know that, well, you can, I mean, it's not very far, right? Again, and second, you can see that because the proportion of the S&P 500 is so big relative to the other companies, right? Like 10 companies, about 20%. So it may be good proxy we usually use as a market portfolio proxies. Now, if you have well-diversified perfect portfolio, your return lies here as this is SCL, right? Only on that, but in real returns we have error term. Basically, we try to make some of these error terms to 0, right? So minimize this actually. That's the best PD line. So to find the way to find this coefficients is actually the same as CAPM, the regressions. So how to find it? You can do the regression models. Now this is the two-factor model for APT, just one factor and two factor. It may be any factors that may affect the individual asset returns, such as the macroeconomic factors, so certain event, or certain any systematic factor, not one specific factor. Any systematic factors that may affect to the individual asset will be the value factor of the APT, and you can actually verify using the regression. Okay. So APT may be used for, the good thing is now we can use this APT model to add more factors, multi-factor models like that, and there's no bindings. We don't have to make lots of assumptions. Arbitrage pricing theory is basically just the assumption is pretty good, because by creating arbitrary portfolio, we know that the error term may be the firm specific risk may be gone by forming well-diversified portfolio. So if we have a well-diversified portfolio, then we can actually apply this model to any portfolio, right? And we can also add any type of multi-factor, like any type of systematic factors. So we can use this APT more broadly. So this is kind of like two-factor model you see, and see that here, if the alpha is 2%, there's calculations here, right? So there's factor 1, factor 2, and it can affect to the, again, portfolio A can be explained by this APT. And you can construct this arbitrary portfolio with two systematic factors. So you can actually form any, like an arbitrary portfolio with any number of systematic factors using this, and then find that this model is valid. So we don't have to worry about now the rational investors or the information symmetric that CAPM model should make. The only thing we can we consider is now how many factors and what factors are the valid ones that may affect to the individual assets return. So this is end of the chapter 7. I know this chapter is not very easy to understand. So there are a couple factors that you have to bear in mind. First, you have to know how you use this model. So like CAPM and APT and Fama French multifactor. Number 2, you have to know how to estimate using regression.